ready when it's ready.
Started.
Started? Okay, so let's get started then. I'm gonna go full screen. Okay, so hey everyone, um, well, good morning, good afternoon, good evening, wherever you are. So this is episode 10, Data Production, hosted by Ashit, myself, Nitul, and Sushant. So in this episode, we're gonna be talking with Nitin Mukesh, who's been a data scientist for quite a few years. And then we'll be having a interesting discussion on some of the things that he's worked on as a researcher and things that he's working on right now. Um, so welcome to Data Science with Nitin Mukesh, Data Production. So let me give you a brief info about who we are if you're joining us for the first time, and then we'll introduce the speakers. Shashid, do you want to go ahead?
Yeah. So, hi everyone. My name is Ashit Dharwal. I did my civil engineering from IIT Bombay in 2021, and I've done two internships in data science. One was in the consumer products division, and another one was in deep learning space in NLP. And I've been a data scientist at Piramal Finance since 2 years now. Uh, and yeah, that's looking forward to the podcast.
Thank you. So a little bit about me. I graduated in 2019. I come from a different background, just like I said. So I did theoretical physics, and then I moved into data science. So my first job was in healthcare as a data analyst, and then I switched to academia. Again, working on Northern Lights as a data scientist, so most of computer vision stuff. And then in industry, so I work for Decathlon Canada as a data scientist since last year. And you can connect with me on LinkedIn. So that's about me, Sushant.
Hi. I am statistics graduate. So I started my job as a data analyst, mostly in the web analytics domain. After that, I moved to retail, where I was working mostly with recommendation and ETA prediction kind of work. And after that, I moved completely to recommendation team, where right now I'm working in recommendation and with the multimedia part. Yeah, right now. That's a brief of mine.
And yeah, you guys can connect with them as well on LinkedIn. Um, so today's speaker, right, Nitin. So Nitin, thank you for taking time out and for being on the podcast. We're glad to have you. Um, and so let me give. Do you wanna introduce yourself, or do you want me to do it for you?
Yeah, thank you guys for inviting me. So basically, I had my BSc in computer science and MSc in applied statistics from IIT Mumbai. So basically, I have I know the basics of computer science and stats well. I think this is the best combination for data science and ML. And I had pretty much a small internship in 2018. Then mostly experience, my all of my experience came through a lot of projects through my faculty and other teachers. I started my job in 2021 as a ML researcher in TCS Research and Innovation Lab, where I extensively worked on reinforcement learning and computer vision. And since last year, I am working as a AI/ML engineer in hair technology. So here I have worked mainly on LIDAR data and computer vision, object detection, and a different bunch of things related to mapping and navigation domain. So yeah, you can connect me on LinkedIn through the link given.
Yeah,
Yep.
connect with him on LinkedIn, guys. That's his link. So I'll also want to give a shout out on his YouTube channel. So Nitin actually uh, runs a YouTube channel. So this is, I mean, you can find it through this name here, or I can even show you guys here. Will be happy to share that link in the chat as well. So you can go check it out. And he teaches some of the math stuff as well as he runs some podcasts as well. So go check it out. Um, okay, well, let's get started with today's discussion. So I'm going to stop sharing my screen so we can get back to normal. Okay, yeah, thank you, Nathan, for introducing yourself. So let's start with your ML intern, right? So I guess you did that internship while you were still a graduate student. So
Yeah.
how was that experience? How did you manage to get that internship?
Actually, that was a research internship. So I was in my BSc second year at Banaras Hindu University, and the motivation for the internship came because one of my batchmate got internship at IC Bangalore. So I think it was a pretty nice thing because as a BSc second year student, we were not hope to get an internship. So going forward to the research internship, actually the I think it was the nice because a lot of people from ITs and different backgrounds has came there for their projects. And I worked on auto encoder, but I think actually I learned a lot from the other peoples from the other colleges. And then I like decided ki like I have to like go above and do my masters and have a solid background for ML and AI. That is why I think that internship started that way.
Okay, that's interesting. So did you get to learn a lot of things while you were doing the internship?
Yeah.
Or was there a lot of challenging to pick up new things or when you were doing the internship?
I think it was challenging because as a BSc second year student, getting started in the deep learning is itself a challenging because what we were taught at the college is a basic of C++, but I myself had to explore Python, the Keras libraries, or the whatever the autoencoder is, read the papers. So one thing I really like from the beginning is to reading the paper. So even if something new is there, like reading the papers and actually getting the stuffs coming out of the papers is one thing that I actually enjoy. And I think I learned a lot from this paper reading.
Nice. Yeah, it's a good habit, right? Reading papers and so you can stay at the forefront of whatever news coming out, right?
Yeah.
And then you can try and apply that right at your work. Yeah, it takes a lot of time and effort to actually read papers and understand them and try and replicate the results, right?
So,
Okay, and
how
then
much
mhm.
how much did your bachelor's in statistics help you in deep learning?
I had my bachelor's in computer science, but the course structure of BHU is really nice because for 2 years you actually read mathematics and statistics and computer science, like the statistics graduate student. So basically, I always wanted to go into the computer science domain, but after the second year, I realized that means AI ML is something that I am actually curious about because I had already explored web development and this website development in very first year. So I thought ki maybe this is the thing that I can pursue next. So when I started studying this uh, autoencoder in my internship, then actually I got realized ki whatever the mathematical equations, like there is a differentiation calculus, real analysis, optimization, all these things come together in the deep learning domain. So I think this mathematics and statistics background helped me a lot, and this is the basic reason why I like understand a lot of basic method described in the papers, because paper itself has a lot of mathematical things, and to understand the papers you actually require like fundamentals clear. And if the fundamentals are not clear, then maybe understanding the core of papers, trying out new methods, or maybe innovating new methods are difficult.
Sushant, you have a question?
Yeah. So basically, just like from where we came, like from our background, like when we are studying in Banaras University, mostly, uh, so mostly till third year, or mostly when we went to MSc, then we start knowing about the machine learning and deep learning techniques, and all these things. These are the market capture things. But when we are in BSc, we are not very aware of these stuffs. So how you get to know about these things, and also in that case, you went for the auto encoder thing. That's really advanced thing at that time, I think. So how you got to know about these things?
So I think most of the motivations came because my peers were really good. So I remember like from that years, my batchmates were really competitive in this particular thing. So and it was really motivating. Like if one of the guy do something incredible, we were actually motivated to do equally great or better than that. And I told ki like in the beginning when I explored the domain of the web development in the very first year, I just got some keyword from somewhere that there is something called ML engineer or machine learning or data science, something like that. And there was one of my seniors from IIT BHU, so he was doing his BTech, and he actually helped me a lot because he was in fourth year when I was in second year. So he helped me a lot, and whenever he used to do something new, so we actually used to discuss by meeting somewhere in the campus. So it was a great opportunity to learn from him, and later he got placed in Goldman Sachs in his very first year. So I think he actually helped me a lot, learning these keywords, or maybe motivating me to do something great in case of AIML, because he was already doing something in these domains, and he actually told me ki you can also do this type of things. Web development is like, okay, you can just do that, but machine learning AI is the new big thing. I think that was 2017, and still it's a big thing, but at that time it was buzzword.
So we have a question in the chat. um, so kindly suggest the way how can we get research paid internships in deep learning sector.
So in India, if you basically want to get into the research internship, so first of all, start exploring the IITs and ISC, because all the IITs and ISC, in fact, triple IITs, ISER, and IITs, almost every institute start their summer internship, and which is basically under the professors, who actually you can get a lot of good work. So I think the ideal time to explore those internship is around Feb to April, because a lot of institutes start taking applications for that. Even if you're not able to qualify that, what you can do, you can mail professors separately. So like this is one of thing that I used to do. I just crafted a good mail. I just shortlisted few teachers from IIT Bombay, Patna, Delhi, Kolkata in my domains, and actually you have to write the mail explaining your domain and what is your area of interest and what are the similar things based on their domain or their area of interest. So I know most of the professors will not reply, but out of 100, if two or three also reply, then I think it's a good chance to take. And I think if you just do this mail technique, then you can also get a good research internship, because mostly these internship in IITs, ISC Bangalore or ISI, these, if you're just getting any summer internship, those are doing actually good work in terms of research and innovation.
Yeah, and I would say also check out.
Yeah.
I'm not sure about companies in India, but check out. Usually, some companies they offer internships. So I would say go also check out companies across India, which is offering internships, and see how can you get in there, right? If you're not from, let's say, computer science background, or if you're not studying that, but you still want to get into that field and get an internship, make sure you do something, some kind of projects, or something that is challenging and that can be used as a way to get into the uh, paid internship role, right? So yeah. um,
Also,
mhm.
uh, also instead of a research internship, you can you can probably get a research kind of a role easier. So, for example, if you choose to go to a startup maybe, and they are working on some problem that has not been solved yet, so your role will require a lot of research to perform, but it might not be actually called a research role. You will be in a like an applied scientist role, but you'll have to read a lot of papers to do that. So that is also a good choice.
Yeah, that's a good point. Yeah, startups. Yeah, because startups are in a stage where they want to try out many different things, and
And
whoever joins in first, they work on many different stuff, right? They got to pick up different hats, put on different hats, right? I think Shushan can share more about that because he worked in a startup.
yeah, so and if you're like messaging young professors like assistant professors in this university, there are more chances you will get the reply from. Like if you are sending someone who is 55 or 60 years of age, then maybe there are less possibility you will get a reply. But this young professor which are coming, they are like more helping nature towards these research projects because they required a lot of people for their research. So
Okay,
yeah, pinging
hopefully we
them on LinkedIn
answered.
or if you got them.
Yeah, hopefully we answered your question. Let us know if that was good enough. Okay, so moving on from your internship and your graduation, right? So after that, you went on to become a researcher, ML researcher at TCS. And so how was that journey from graduating? Was it did the internship help you to get that role, or did you have to go through a lot of uh, you know struggle to get into that role?
Okay, so during the placement, I remember being a researcher or maybe working on research domain was my first priority from the beginning. But yeah, in the placement, I was trying all the companies, banks, finance institute, everything, and sometimes software engineering also because I had a good coding and coding skills and web development projects. But like ultimately, I end up in TCS research, and I think that was a uh, good part of my life because uh, after getting rejected from a lot of companies, now I had in mind to whatever comes, I have to go. But once I got selected in TCS research, like I myself focused on I have to be in the research domain as much as possible. So there also, like I was in the TCS, the culture in the TCS is like that you will be uh, given a project based on your skill set. But like there is so much crowd inside the TCS, people actually know nobody cares about what is your interest and what your skill set are. So they want you to just get you to adjusted into any project. So that is what I dislike about the TCS. And I was actually I was given a support project which I later came to know, but I just genuinely refused. I cannot do support project. My role is as a researcher and I will only do research role. Then after a lot of like a lot of discussion and all those things, I got into a research project. Actually they were trying to do some computer vision classification method using reinforcement learning. So that was just a concept. Maybe we can we do classification or this thing using the uh, reinforcement learning or not. So because I had not any interest in the reinforcements, I had no any background in reinforcement learning. But when I started learning the RL, I came to know that it's just an extension of a stochastic process. So applied stats, we had a stochastic process, we have Markov chain. So just if you extend this particular method, Markov chain is actually very common thing in the reinforcement learning. And like every RL process is itself denoted as a Markov chain. So later then I just realized that whatever I have studied is just coming into picture slowly. So that is the, I think my MSc degree helped me a lot to like study these things RL and grow in it.
Okay, and
So
then
did
sorry,
you
yeah, go ahead.
did you decide to go for MSc after TCS?
No. Like I'm telling ki whatever I had read in MSc, that helped me a lot in
Okay.
like going forward in TCS.
And what made you do MSc?
First of all, speaking genuinely, like in BHU, BSc has no any good placement, and
Hmm.
getting a job after BSc is also not good because you will always be means your degree will always be like a junior degree. Like people will not actually follow up whatever knowledge you have, or maybe you are not going to get a lot of good opportunities after BSc. Maybe like the struggle can be there, you may get, but I think the way to make your path easier is to get MSc. And I think getting MSc in applied stats was a real struggle to me because I was a computer science student. I had a little background in maths and stats, but I had to work hard because applied stats is mostly mathematical. Like it is 80% mathematical, 20% computer science. So we had a course from computer science also, but like out of 6 courses, 5 were from maths or stats domain. So that's pure math, like real analysis or combinatorics, linear algebra, probability and statistics, and that is also starting from the measure theory or statistical inference. So I think that was a real struggle to me. And I think doing MSc helped me a lot because that made me actually think algorithms statistically rather than computer code. So earlier I used to think that if you have to fit regression, just write the code. But now I never never think about it. I just, yeah, if the just start from the data, see if the uh, whatever the model are fitting, is the variable significant, is the model significant, is the model satisfying the assumptions or not. So whatever may be the basics of regression, just I follow that, not as a code wise, just fit the regression model, give the prediction. So I think getting an MSc was a nice thing for me.
And then so how did you decide, right? So you did a ML intern, right? So which was more research oriented, right? So after your graduation, so what made you decide that okay, you want to go for more on the researcher side and not on the applied data scientist side, right?
So, I just told ki means I myself was into the research. One thing that
Mm-hmm.
fascinates me a lot is about reading papers, writing research papers, making innovations. So this here technology when I joined, till now I have filed three patent. So I think whenever a patent idea, like I used to think a patent idea and it's actually a good idea, then that is actually I think it gave me a better feeling that I can think of something new in the domain of deep learning or graph neural network. So I think that seems fascinating for me to read research paper, write new things, and do the innovations, try to solve something that is not has been solved yet, or maybe you will require some new method to solve that particular problem. So I think this particular thing excites me, and that is why from the beginning I just wanted to get into the research. But I told in placement I was trying all the companies, but it happened I just end up in the research and just I tried to continue that move.
Mm-hmm. So a lot of people who want to go into research, they end up at some point they end up doing PhDs and then go into that research domain, right? That's the
Hmm. Hmm.
flow, right? So for you, was there a reason why you didn't want to go for a PhD, or was it is there a lot of jobs out there for researchers just with the MSc degrees? Um,
Yeah, I think
yeah.
after masters, maybe MTech or MSc, you can get to a good research positions inside any companies. And there is also option if let's say if you want to continue in the job and you want to do PhD. So if you have 2 year of experience, I think you can apply for PhD through India across any IITs or ISC, because I recently started to explore these things, and I recently came to know that if you have 2 years of experience, you can start external PhD. So one of your guide will be your companies, some of the person from any companies, your companies, and one of the guide will be from the college, like in professors. So you can just do your work, and as part of your work also you just continue to do your research along with your guide and co-guide, and you will receive your PhD within like whatever the time period, 4 to 5 years. So meanwhile doing job you can also do PhD. But yeah, I think that requires a lot of hard work, because after job you have to focus on papers and all those things.
Mhm. All right. Okay. And then for your, so can you walk us through, what's a day to day looks like for an ML researcher? So,
So
what do you do during that day? Hmm.
yeah, I will try to focus this using two scenarios. So one scenario is when we are not doing any development project. So as a ML researcher right now, also I'm in the technology innovation lab team. So we whenever we're not doing any development, we are actually trying to let's say some customer come or some project come and they actually need some new type of solution. So first, like the naive method is to just see any papers that has been implemented using that particular problem. So mostly in navigation and mapping, there has not been a lot of innovations regarding AI ML thing. So a lot of things are not there. Means no any direct access or no indirect methods are there. So first thing is key just understand the problem and try to come up with a new method. So the day to day one is to, let's say you have an idea, so just refine that idea, make that idea, or just bring that idea into a point where it can be executed. So let's say that particular algorithm is there, and we just came out to we know that this is a new algorithm, so we can file a patent. Once the project start, we will do a sample implementation. So let's say we have a data set of, let's say, 100 TB, but we want to do the implementation on 10 GB data just to see if the algorithm works. And now, as we need to scale this particular thing, we need to start from the how can you optimize the server, how can you optimize the training, how can you optimize the inference on 100 TB of data. So these kind of things regularly involve day to day discussion about if what can you do to optimize these things. Or maybe if certain, like let's say our code is in production and certain error is coming, so just go and debug the error code, or just find out where the error is coming from, why this particular thing is happening. So these particular things is happening starting from the innovations to till a project is implemented.
Okay, interesting. And then so you chat here technologies. Do you want to give like a quick brief overview of what you do? Because I think I have Yeah, I have questions on what you do. Follow questions on that. So do you want to give a brief overview of what you exactly do?
So first of all, let me give a small background of Hair Technology. So Hair Technology is a mapping and navigation company. So we have our own map, Hair Map, and I think it's a number one location platform company inside in the world, ahead of Google Map also. So mainly, people generally ask you, why do we not see Google Map on our phone? So sorry, this Hair Map. So Hair Map is not open for us. Like, it has been used by its customer, mainly owners like Audi, BMW, and Mercedes. So these are the joint owners of Hair Technology. Some shares has been also with Mitsubishi and Nokia. So basically, Hair Technology had a this history because it was a part of Nokia. It was earlier Nokia Maps, and once it's got released from the Nokia, and it has independent owners now, Audi, BMW, Mercedes. So most of the project come from the Audi, BMW, Mercedes. A lot of projects come from other automobile vehicles as well. So we have our own map, and a lot of works goes on updating the map, but that is for separate other teams. I'm not on that particular team. So our means my team or myself, as we work on, let's say some new problem is coming that actually requires some use of mapping and navigation. So we have to, like, on my team there is one software engineer, like two software engineer, two ML engineer, and one is GIS person. So that GIS person is actually who is taking care of all those GIS data, and he has a good expertise in that domain. So we all together sit to find out if this particular problem is there, then what we can do to solve this particular problem. Maybe some part require AIML development, then maybe certain part require development of an Android app, then certain part require integration of AIML output to GIS information. So this means this is not a typical ML project. This is actually you can say combinations of all these things coming together. So this is like typical work we do. So mainly whatever the work is coming, it just maybe there is a ML implementation, ML method. Maybe we have to integrate into the software, or maybe we have to like create new software where people can upload the data and get the output in the desired form without understanding, without getting into the technicals. So if, let's say, if I develop the model also, then some people have to develop the app or software, or some people have to do the deployment, or just monitor the deployment. So like this small team is actually responsible for end-to-end project, starting from date. Sometimes we also have another team for data collection. So starting from the data, raw data, to the end to end the tools or software, or maybe the entire project.
So just to understand this, right? So you said for certain cars, right? So you guys do things for them, right? So if you take an example, right? So in those cars, so on a display, the maps that they have on the display, so that's not Google Maps. That's the ones that you guys provide.
Yeah.
Okay, so then whatever features and everything that exist in that map, so
Hmm.
you're trying to make that more efficient and better user interface and et
Hmm.
cetera, right? A lot of ML
Hmm.
technology behind the
Yeah.
scenes.
Yeah. So
Oh, interesting. I didn't know that. Okay.
so like let's say like the basic of the navigation and mapping companies are the latitude and longitude. So let's say I
Mm-hmm.
just capture a photo of any particular restaurant, and I just tag my latitude and longitude. Then using those particular photo, if I get latitude and longitude, I can exactly locate that particular thing on the globe, or on the map. So there are a
Mm-hmm.
lot of solutions which actually requires them to locate something. Let's say we can detect some object using object detection algorithm, and we want to locate it inside the map, on the map, where it is lying. So these
Mm-hmm.
kind of things, whenever it requires solutions, it will be from some mapping and navigation domain companies, because we have our own map, we have our own in-house software for that. So whatever basically we have to do is to just create a AIML thing, and just we have to integrate it out with our own in-house software. So that is, this type of projects are mostly that we do, because anything that has latitude and longitude, it is actually of our interest. So maybe it's let's say you are from you have any banking data, you have all the details of a customer taking credit card, and you have his latitude and longitude, then also it can become interest of our company.
Mm-hmm.
So that is how we, like, let's say if you have a location of any person, you can actually have a lot of information about him. So like location have a lot of information about, let's say, per capita income of that particular state, or whatever the job
Mm-hmm.
status is in that particular area. So those kind of things are there.
Yeah,
Mm-hmm.
even in banking, so we also use third-party data of location. So if we know the exact locality of a person,
Hmm.
we know a lot of things. What kind of
Uh-huh.
house, what kind of houses are there in that locality? So from the kind of houses there are, you can actually get a sense of what exactly is the family income, right?
Uh-huh.
So
Yeah, no, that's it's interesting, right?
I
Geographical
think
data can help in so many
Yeah.
sectors, right? Yeah, Shashank, you're saying something?
yeah, I think location plus the financial data, these two, if combined, they are the most advanced technique to reach someone through the ads. Like you know where they are and how much money they have, so you can target at advertisement on the
Yeah.
basis of that. So
Yeah. Even in the retail
one of
industry,
the
it's used a lot. So recently, I was doing a project for the Catalan. So we have new stores that open up, right? And so anytime they want to open up a new store, the first thing they want to do is they want to know a little bit about the customers around that area, right? And so we have customers data. The store that's already open, we store data about customers and where they come from and so on and so forth, right? Because we do deliveries and all that, right? And then based on that information, you can exactly know, in that particular area how much share it's gonna be, right? How much and how much customers spend on the products, and even way before the store opens up, you already know the market size.
Hmm.
So there's a lot of things that I think one can do just knowing the geographical data, right?
so
Yeah.
so
and
Nitin,
one
do
thing like this financial one thing is like the credit is the basic example of it. Currently, the credit is working completely on this only. They just have your credit card data, and now they started becoming a retail business also, coming into a retail business also.
Yeah, I think this type of data has a lot of value to other companies also, like not as a financial institute. So, like one of the classical problem is to whenever people used to feed their addresses on the, let's say, Flipkart or Amazon, whatever they do, they actually don't fill their exact address. Like some people just fill their
Uh,
parcel address. So, like whatever the company do based on the pin code, based on the some keyword of which address, they try to retrieve the full address from their map. So this is also one of the classical problem people come up with.
mhm.
yeah.
Then you mentioned about LIDAR data, right? So what do you want to explain briefly, what a LIDAR data is to
So
users if they don't know? Mhm.
yeah, so like typically whatever the data we see till now, like the if we have image data, then it is a matrix of pixel. If we have numerical data, then it's a numbers. So like LiDAR data is typically have only six features. So it's just a 3D point cloud. So let's say I am seeing this particular object. If I just like using a LiDAR sensor, I just like throw the light rays, and just if the detections comes, if the returning is coming, I'm just capturing it through some device. So it will give a point cloud of this particular 3D object. So if you just visualize inside the point cloud software, it will give you just a 3D dimensional point cloud. You can just rotate it, see it from every angle. So for each and every point, so it's just a point cloud, like you can see the shape of this particular thing, but it will be just a point cloud. It will be just point
Uh-huh.
collection of point, millions of billions of point. So for any particular point cloud, what we have basically six information. First of all, it's xyz coordinate. So let's say I'm maybe I can use any coordinate system. Let's say I'm using Indian coordinate system. So if I just my LiDAR using in Indian coordinate system, then it will give this XY location of this particular thing, which can be located on the Indian map. And then Z is the like whatever the height of the height from the ground. So like basically we can exactly this to this particular point. Apart from that, for any particular point, we also have RGB features like red, green, blue. So if this point is a colored point, so it will have a RGB features, which will be basically the colored combinations of three code RGB. Now using this particularly six data, we what we have to do, like there can be also other kind of informations, like maybe let's say if a particular light ray is coming through this particular point and it is getting reflected, it may also happens that means what some portion of this light rays also penetrate this particular thing and then again reflected by second layer of this particular object.
Hmm.
So this is called the number of return. So basically, LiDAR has single return and multi-return. Multi-return means it just get a return from a simple object, then also penetrate, go inside, and just get reflected from second layer, then third layer. So let's say if you're just like throwing LiDAR over a whatever water body, it will just return from the water surface, then the shallow surface of this particular water body. So you'll also know to get the height of like what's the depth of particular water body. So using these six features for any particular point, let's say we have a million of point cloud for this particular object, and we had similarly thousand of object. Then what we can do, we can train a model. When we will give a point cloud, it will just give you what is this particular object is. So like in the image itself, let's say we are giving it as an image of cat or dog. So it is able to identify if just train the model based on that. But this particular point cloud is not a typical method because it has only six features. Like each point has six features. So let's say this particular object has point cloud of 10,000. So our matrix will be 10,000 cross 6. So this is typically very unstructured data, you can say, or very unconventional data that we need to handle. So there are three kind of problem actually defined on the LiDAR data. So first is object classification. Like let's say we are trying to identify entire point cloud as a single object. Second can be object part segmentation. So object part segmentation means, let's say this is a mic. So maybe this is the handle of mic. This is the mic. This is the front portion of mic. If some chair is there, then the leg of chair, hand of chair, or back portion of chair, the flat portion of chair. This is called part segmentation. And third is called semantic segmentation, which is actually given a large area. We have to actually segment the larger things. Like let's say this is a water body, this is a trees, or maybe this is a forest, this is a railway track, this is a road sign, this is a building. So this is like doing segmentation on the large object. So these three are the classical problem on the point cloud. So basically there are different methods people are actually inventing starting from the 2017. The first method voxel net is there, which actually started in 2017, and after it a lot of new methods came for implementation of like identifying the objects using LiDAR, or maybe doing segmentation, part segmentation, something like that.
So I have two questions. So first is so let's say you shine some light on an object, and depending on the surface of the object, it will get reflected uh, all around, right?
Hmm.
So where do you catch this light? So you actually need to catch it to get the point cloud, right?
Yeah, so like there is something called sonar, which is we throw sound wave. So LiDAR means light detection and ranging. So there are typically device for that. Let's say we want to do LiDAR survey of this particular area. Plane will fly through that, and there will be LiDAR sensor installed in that, which will just throw the light rays and capture the light rays. So those LiDAR devices are installed on the plane itself, which is taking the survey. So people also take survey through like LiDAR, installing the LiDAR device on car, top of the car, or maybe some other drone or something like that. So the device LiDAR sensor is actually used to throw the light rays and capture the light rays and just make the point cloud
So
in the
it,
background.
it will only capture the light that has been reflected to that exact
Yeah, yeah.
point, right?
Means yeah, you will find that ki somewhere the point is dense, somewhere the point is shallow. So that is
Hmm.
because if the light is directly coming from that particular point, so that will be very dense because all the points will be from that particular area. Let's say from the back of this mic, let's say there's some light rays is coming from this side. So back of mic, very less number of light rays will get
Yeah.
reflected. So that will be there you won't find any what you can say a lot of dense region. That will only one or two point you can see.
Okay. And the second question is, so like we do object detection on normal images. So that is like 3D data, right? No, 2D data.
Hmm.
So, and LiDAR, you have 6D. So, uh, is that the only difference when you are training an object detection model, like 2D to 6D, or is there any other difference?
Actually, the main difference is, let's say if we just see image, we can actually see it in plane. So we can just keep an
Yeah.
image and see it in plane because it's a matrix. But if we just see a point cloud, we need three dimensions. So it's a three-dimensional data. But whatever happens is that like image is symmetrical. Let's say we are trying to just send 28 cross 28 image or 140 cross 140. 640 cross 640. So we know that we can resize this image in this particular format. But the problem with the LiDAR is that we actually don't have this like n cross n or p cross p structure. We have
Mm.
something cross 6. And
Yeah.
also not all the objects will have same number of points. Some objects have 10,000, some maybe 1,000, some maybe
Mm.
50,000. So these are the typical problem. And also, like whenever we see the convolution images, so let's say image is there and we are just taking a convolution matrix, just sliding, like we can picturize it. But in the
Mm.
terms of point cloud, we cannot even picturize because it's not an image. Like, in the beginning, I used to see that, okay, it's like this is how a 3D mic looks like in the picture. Why not we just take the picture and feed it in the CNN? But this we cannot do because our interest of our area of interest is each and every point. So whenever we do classification, we know that this particular point actually belong to this mic. So we want to have information about each and every point. So basically, like whenever we identify a dog in the image, we just put a, what you can say, a square matrix, because you know
Box.
the dog locates in this particular pixels. So obviously, if you just want to locate a mic in a point cloud of a room, we just have to know, okay, these 1,000 points actually belongs to mic. So just taking the picture of this particular 3D point cloud on any particular
Mhm,
software, it will not work, because this is not, we are just changing the entire problem itself.
Mm.
mhm. People who are wondering, how does the LiDAR captures all, different penetrations? So one thing I can mention is, so think of electromagnetic waves, right? So each of them can penetrate different depth, right? So you can have radio waves that can penetrate through certain stuff, and then it stops. Then you have gamma rays and X-rays, which are highly penetrable, right? So sometimes these devices, they use whole electromagnetic spectrum in order to capture every single thing that they want to map it out, right? So you can get to any depth they like, right? For example, so we have telescopes, right, that is taking pictures of the night sky, right, galaxies, and all of that, right? So
Infrared.
yeah, so right, the infrared, right? So we have a Hubble Space Telescope, right, that's to take pictures so far. So yeah, so some of these, they're invisible, but they're really good in terms of picking out objects that are not visible to naked eye, let's say, for instance, and that are far, far away, right? Um, okay, and then so you mentioned, these six features, right? So every point has six features, right? Um, and so is this how you go into the venture of graph neural networks away from
Yeah,
CNNs?
so like when I started working on the LiDAR, I just read some of the earlier papers from 2017, 18. And like their method was very obvious. So what would they do? So let's say we have a 3D point cloud. So they used to make 3D cubes on the entire point cloud. So let's say this is 1 meter cross 1 meter cube. This is 1 meter cross 1 meter cube. Let's say it's a point cloud of a large room. And let's say in a 1 meter cross 1 meter cube, they have like there can be 10,000 points, there can be 50,000 points. So they just fixed a number of points. So let's say they fixed 4,000 points. So whatever they will randomly sample 4,000 points from that particular
Mm.
cube. And what they do, they just like let's say this is so whatever they do, they just feed the entire voxel into the CNN. So what they described, so they just make a 3D structure of a cube, and let's say the number of points inside this particular cube is 4,000. So if the cube is 32 cross 32 cross 32, so let's say length, breadth, and height, or maybe 1 meter cross 1 meter cross 1 meter. So they used to run a convolutional 3D convolutional what you can say filter inside that particular 3D cube. But it is very heavy method, because unlike the images where we have maybe 640 cross 640, or this particular thing inside a large point cloud, if you just convert it into the cuboid or cube, that is pretty heavy method, and that was actually very slow method. So what the people try to think, why not we can feed point directly into the neural network? So people came up with a paper called PointNet, where PointNet is directly feed point into the neural network. So what they used to do, they let's say they what they need to do, they just started creating features from the initial point cloud, or you can say that key. what the term is, embedded, what you can say, their features, embedded features, and then they started forwarding those features into the neural network. But some people come up with the obligation that okay, what we can see, we can create graphs rather than creating the feeding the direct point. We can create a graph and we can start feeding some group of point. So people started creating Canaan graph. So Canaan graph means, let's say I'm choosing k is equal to 30, so it will just connect its edges randomly to the nearest, like not randomly, nearest 30 points. Each and every points will connect its edge to the nearly nearest 30 point. So basically this what this helped, this actually gave the application of how we can apply graph neural network in the uh, point cloud, which is very obvious case. So whenever we actually apply graph neural network, so graph neural network basically means that we are feeding the graph in the uh, neural network. So like if you just go to the very basic, so you can see that if the this particular point is connected to its neighbors, that is connected to some other neighbors, and this way. So after the training is done, so what my people came to know that features like the information from the very last point cloud actually travel to the very first point cloud, because those points were connected among each other, because they were neighbors of some other point. So this actually increased the accuracy of classification segmentation by a lot of difference. And like recent papers that are coming were from the graph neural network, but like people started exploring the domain of transformer or some other method, like how we can apply those method to just do the classification. But I think graph is very natural method, because this is what we actually understand key. If this is a stand, we cannot decide if it's a mic by just looking at the single point. We have to look at entire picture. And if the information actually travels from the very first point to the very last point, I think that is very natural method to say that yeah, this is a this is also what we perceive as a human. Like whenever we see any a smaller portion of the object, we cannot tell what this object is unless we see the full picture.
That's a yeah, that's a very valid point. Yeah.
We have a
So I'm gonna
question
take two
from chat.
questions. Yeah.
Yeah.
Mhm. So I think one of them is from Rahul, which we already answered, which is, I wanted, so he says that I wanted to get an internship in AL, ML, NLP, DL. I think we already answered that question, but just to, quick 30-second thing. So, you can go check out universities across India, see which of them are offering internships, reach out to, professors who are offering internships, but make sure you know which domain you want to go into, because this NLP, DL, they all are, pretty big domains. So you have to narrow it down to which field you want to go into. And you should also make sure you know things right before you reach out to them. Don't just reach out to them saying, hey, I want to get an internship, because, there'll be so many people who are reaching out to them, right? So make sure you know in and out about the field. Um, then we have another question from Ritesh. He says, can you tell us the list of topics in statistics that data scientists should know?
So basically, if we are not from MSc statistics or doing any specialized course in statistics, then sometimes it becomes difficult to like find which topics is actually necessary. Because as a like if you're doing MSc, by default you are actually studying a lot of things, and even if some subset of topics are asked, you will be able to answer. But like whatever I have felt, like whatever the people ask in the interviews and people actually use in the industry, so just start from the basic of probability. Just read till the base theorem, because that's where probability actually gets complicated. Then start from the basic of the data, like what is the data, what is the nominal variable, and all these kind of things. How do we do data analysis? Basically, the kind of graph, the bar chart or the box plot or whatever the plots are. They just try to understand their basics. How do you actually interpret those things? Then just start from the random variables, because what random variables you cannot skip. Just don't go solving thousands of questions. Just read the basic, the PDA, PMF, the mathematical expectations, the variance, because variance standard deviation is a very pretty much standard thing inside the ML industry also. Then you can go to this a statistical inference. Just try to read some basic of the inference and hypothesis testing. and then I think you can just have a good background till hypothesis testing, and then you can start learning data classical ML algorithms, especially regression in detail, because regression is not just fitting the line, because a lot of things are there in the regression that people need to understand. I think the nice book to follow is ISLR, Introduction to Statistical Learning. I have myself learned ML not through any courses, but from these books. I also in the beginning used to explore a lot of online courses where I used to think that the courses are good, but I think this book will give a lot of information regarding implementation of any algorithm, or maybe mathematics, or whatever the extra information you want to know about any ML algorithms is there in the book. Especially classical ML is discussed very nicely in this particular book, starting from whole regression, like regression, multicollinearity, the local regression, the spleen regression. Each type of regression is there. Logistic, then logistic regression is there, and support vector machine, PCA, this k-means clustering, some basics of neural network has also been added in the second edition. Then you have this L1 L2 norm, whatever you want to study, L1 L2 norm, and some methods have been also some topics have also been included from hierarchical clustering, and this book is pretty good for learning the basic of machine learning. But yeah, as per statistics, I think probability, a little bit of inference, hypothesis testing, or distributions is these are the standard thing to know, because this will be expected from you always at any interview.
Shashank, do you have any input since you're
Yeah, so
from
I want to add
stats?
here, like,
Mhm.
yeah, so it depends mostly in which field you want to go. Like, let's say if you want to be an ML engineer, you need to know a basic of statistics. Not, I will not say basic of like probability, inferences, and like normal EDAs, like graphs and all. These things are important. But if you want to go into research field and like we can say that the probability theory is similar to the if you talk about in software development, this DSA is similar to the probability theory. So when however you want to go deep inside the any algorithm, you need to know the probability theory, like the measures, random variables, and all these theories. So for for that we need to understand more of these things. But if you want to just go and understand the algorithm, implement it, and deploy it on the production, I don't think that you need a much of statistics in that. You need basics of statistics like Python, probability and inferences, and some of the testing of hypothesis part. Apart from that, but when you want to go deep inside the algorithms, you need to know about this probability theory, linear algebra, and all these stuffs.
And I just
And
wanted to mention. Oh,
as,
sorry.
as
Yeah, go
as
ahead,
Nitin
Shashank.
was talking about the ISLR, yeah, as Nitin was talking about ISLR, now the ISLR has been updated, and now they also added some deep learning
Hmm.
topics in their book. So
Mhm.
I also studied my machine learning from this book, and this is quite interesting book if you want to follow. And this is really very from starting from very basic, and you will get a deep knowledge of how the theory behind the machine learning works.
Mhm. And I just wanted to mention a couple of things actually. So first, Rahul, about the internship. So I assumed you were looking for a research-oriented internship. So that's why I mentioned universities. But if you're just looking for, industry level internships, so then, there are a lot of companies who are offering internships. So one of them is actually Ashit's uh, company, Pyramid Group. So they offer internships. So do check it out. Yeah, I think there are a lot of companies across Bangalore as well who offer internships. So check it out. Um, Recently I got to know that Google is actually offering internship um, in India. So you can go check. I mean, I don't have the post where it is, but
Most
I can.
companies hire interns. Yeah.
Yeah. Uh, so that's that. And then as per the second question about stats, so a lot of companies they have different data scientist roles, right? So for some of them you might see product data scientists, right? Now that's where you need to know a lot of A/B testing, right? So that's where it becomes sort of stats heavy. So depending on what kind of role you apply to, like Sushant Nitin mentioned, right? So you need to know the depth of stats. So if you're applying for product data scientist roles, make sure the different ways of doing A/B testing, and so on and so forth, right? And then if you're applying for just a general data scientist role, then knowing just the basic is good enough. And there are a lot of books that you can follow. Nitin and Sushant mentioned one book, right, which you can follow, which walks you through the theory as well as I think it walks you through the coding as well in R, if I'm not wrong, right?
Yeah.
And there is another book that I used to read when I was trying to get into the field. It's called 100 Pages of Machine Learning. So the guy has tried to compress the entire machine learning in about 100, less than 130 pages. But it mostly explains you the theory, but it's a really good book. So I would encourage you to check it out. If get a quick overview of what is machine learning and so on and so forth. So it's that. We have few more questions. So yeah. Sorry, Shishant, you were saying
And one
something?
more good thing about this book is, yeah, one more good thing about this introduction to statistical learning book is that there's another course which has been designed such that for each chapter, their authors were talking about all these stuffs, and they are trying to explain in the video also. So it is also very good, interesting point in that.
Mhm.
Yeah, I think the
Yeah,
course is on EDX.
exactly. Yeah.
Yeah.
Thanks for mentioning that. Yeah, the course is online, so you can go check it out. I think it's on their university website as well.
Yeah,
This
yeah,
was a long time
Stanford.
ago. I don't remember.
Yeah, Stanford.
Yeah. So yeah, do check it out. It's all open source, so you can go check it out. So we have another question, follow-up question on this. So first, let me take the A/B testing one. So it says also how can I start learning about A/B testing? Anyone want to answer that?
Nitin should
So how
answer.
can
I think you should answer.
statistician guys? I can start that if you want. So learning A/B testing. So one way you can learn it is, um, so pick any. So I've been learning about a lot of A/B testing myself actually. Pick any stats book, pure stats book. First, learn about what is hypothesis testing, right? So start learning about that. Then start learning about the different tests that you have to do, right? So start learning about those, and then go on take some courses which are particularly specific to data science, right? So A/B testing in data science. So if you're doing data, if you know datacam has a lot of courses on A/B test, how to do A/B testing in Python and R, right? And this is more from the data science perspective. And you'll find lots of resources online as well. On Coursera and EDX, there are lots of courses which teaches you how to do A/B testing, again, from data science perspective. So I'd say, it'll be a lot of reading material to get started. And then you can start applying to the project that you're working on. That's the best way to learn, I would say.
So Shant, you
Any
have
other?
that Art of Statistics book, right? Does it have A/B testing?
No, no. Basically,
Yeah.
if we most of the statistics book don't have A/B testing.
Hmm.
It came mostly from the management books,
Hmm.
like those who taught us like product management on all these stuffs. They mostly use A/B testing. And there are lots of online tools where you just put the numbers of the samples and you will get the directly results of A/B testing. So like in my previous organization, I was directly using that numbers, and that also give you the how much confidence interval you want and all this stuff. So I think that's also a easy way where we can use the A/B testing. And there are more like right now in my current organization, there are many companies which provide A/B testing tools, so that can be used directly by the product manager. So we are
Hmm.
not much involved in the A/B testing part. We are just
So
Yeah.
involved in the inference part.
uh, yeah, like our company just started doing A/B testing actually because we are a marketing team. And so, sometimes when you have like large retailers or some companies where they want to run some marketing campaigns, that's where, A/B testing comes into the play. And then you have to do like in-house A/B testing and so on and so forth, right? So, yeah, depending on how deep down your company wants to go into, can go for it. So I'm going to take another question from someone, unless you guys have anything to add.
So
Do you
in
guys
terms
have
of
any?
if you just want to do learn A/B testing just for the interviews, there is a good book called Ace the Data Science Interview by Nick Singh. You can
Mm,
just go through that. It covers most of the topics asked in data science interviews. But if you want to go into depth, then I think you should do a course or read another book which goes into depth.
yeah. Yeah, I think in future sessions we'll put together some resources and we'll share. So I'm just putting the book in the chat that I should just mention is the data science interview. So that's a book you can find. I don't know if it's a free copy available, but yeah. So another question we have is, do you think it's important to become a good software engineer first and then slowly transition to data science and ML? Is there a huge intersection?
This we
Uh,
I
can
have a lot.
cover in the course slides.
Actually,
yeah.
yeah, we can
Yeah.
cover this. But Nitin, do you have any input you'd like to
Like
give away
I
right now?
myself, what I have felt like initially I used to do web development. So like whenever end-to-end projects come, I think the approach actually helps. So let's say we want to design a system. So basically, those approach actually helps. Ki how will we scale the model, or how will you just carry out end-to-end things. Like I myself sometimes do some apply some techniques of web development to like build some small tools for ease of access. So rather than just going and writing code each and every time, just I have to press buttons and do the things. So
Yeah.
just for the my own sake of simplicity, I just sometimes do that. So that's not the case, but I think overall, if you're designing any machine learning system, you're starting from any scratch, just thinking about how the process will flow. I think at that particular place, this particular things helps a lot.
Yeah, and we'll talk about more on this. So when we just discuss about our course that we're
We
offering,
can
I
jump to
just want to
that
mention.
quickly. Yeah.
Yeah, you can jump to that. Actually, yeah, we can wrap. So I think it's been an hour, so we can wrap up with Nitin. So Nitin, thank you very much again for taking time out and sharing your insights. And I think it's very valuable to everyone who attended. Hopefully, they got to learn a lot from this podcast. So now we're gonna kind of switch to the mentoring, the courses that we're offering, and so on. So if you'd like to stick around, feel free to stick
Yeah.
around.
So
I'll leave that on you. Okay.
yeah,
All right. Anything that you want to mention one last time to users or freshers?
I think it was really a nice talking with you, and I think you guys really brought up some interesting questions that actually we discussed a lot. And I think the podcast where two, three people are simultaneously involved in the discussion is better, because a lot of things actually comes up during the discussion itself. So thanks. I think it will help everybody a lot. Thank you.
Thank you. Yeah. Okay, I'm gonna start sharing my screen again. Yeah, Shruti, if you stick around, we'll answer your question now. Okay, let me see. Here's the one. Okay, you guys can see the
Yeah.
slides. Okay, good. Okay, so I'm gonna go full screen. Um, so bringing to the topic of knowing, is it better to become a software engineer first, then transition to data science, and also things that you should know to become a better data scientist, as well as the field is competitive right now, right? So just doing boot camps, it's not going to help you land a job, right? So what are some of the things that you should be knowing in order to become a better data scientist and stand out in the crowd, right? And this is where we started offering. Actually, hold on a minute. I'm gonna quickly. And guys, I gotta open the window.
Yeah.
Okay, I'm back. Okay, so we started out. We saw a huge gap between boot camps and what people should know or when they want to go into industry, right? And this is where we decided, okay, we're gonna start offering this mentorship program where we can teach people how to learn all of these tools in a single project, right? So boot camps will teach you Python, right? How to do things in Python, and how to do projects and so on and so forth. But you gotta get away from Jupyter notebooks, right? Not just do things in Jupyter notebook, things from the perspective of software, right? So you should know tools when you go out in industry, right? So Python is one of them. You should know some cloud platforms like either AWS or GCP, right? You should know SQL, right? Because as a data scientist, you interact with databases a lot, right? And this is where you start your journey as a data scientist, right? The first thing would be to go and get the data to work with. Without data, you don't have anything to do in Python. So running SQL is the key, right? And then GitHub, right? So when you go and work in very large organizations, you work in a collaborative team and a cross-functional team, right? So knowing GitHub simplifies your life a lot. So knowing how to create PRs, how to do code reviews, how to follow best practices in terms of coding, so that you make others' life easier, right? Because you work in collaboration with your teammates, and you don't want to write a messy code where your teammate have to scramble through the code, try and understand what the hell you've done, right? So knowing best practices very important as a data scientist, and that's what's going to differentiate you from other freshers out there, right? Also knowing CI/CD, right? Now a lot of things are getting automated, right? So let's say you do a project, right, and you need to you get a data every week. You're not going to manually run Python scripts, right? You're going to spend an hour sitting down there just running Python scripts. You don't want to do that. You want to automate that task, and this is where CI/CD comes in, right? And also you push things into production, right? You don't want to push bugs into production. We all hear people saying things break into production. So how can we resolve that, right? How can we make sure that things don't break into production, right? And this is where again CI/CD comes in. You catch bugs before you push your code into production, right? And things like Jenkins you can use for that, right? CI/CD, there's a GitHub action, so on and so forth. And the most important one is the software development cycle, right? And then following this whole approach you know will not only make you a better data scientist, but more opportunities will open up for you, right? So starting off with planning, doing some analysis, design, implementation, you integrate some testing to catch bugs, and then once you push things into production, you have some maintenance, right? I mean, once you push models into production, you're not done, right? You still have to maintain it, monitor it, so on and so forth, right? And then you work in an agile process, right? So every small changes you make sure that you push those changes into production and not wait for months. Then they realize like, hey, this is completely wrong. I should have done something else and not this one, right? So a small iteration, and then keep pushing into production. Um, so Shruti, to answer your question, yeah, it's good if if you have worked as a software engineer, but if you haven't, that's okay. I didn't work as a software engineer. I don't think Ashit or Shishant or even Nitin, right? So Nitin did web development, but none of us worked as a software engineer. But that won't stop you from becoming a better data scientist, and software engineers don't learn about machine learning algorithms and so on and so forth, right? What the key thing that you take away from software engineering is how to be a better programmer and think from the perspective of programming, right? So that's what one key thing that you take away, and applying software engineering principles, right? So we started offering this course where mentoring program where basically you'd come and work with us, and we go all the way from raw data. We'll actually build the data engineering pipeline, ETL processes. Then we'll also do some data science. We'll do modeling and so on and so forth, right? Follow best practices in coding, and then we will deploy, and also you'll create dashboards for apps and so on and so forth, so that you can communicate with stakeholders. And in all of this process, you would learn these different tools that I've listed out here. And the key thing that I focus on is the best practices and software engineering principles. These are the key takeaways uh, that's needed, and you're gonna learn from this mentoring program, right? Um, so what you get out of this if you were to join us? So you get to work with me and Ashit in a collaborative mode, and the project can be, you can think of this as an internship, right? So the project can last for 2 months, and within 2 months you'll have one whole pipeline, end-to-end pipeline built by yourself, right? um, and we are offering one-on-one mentoring. So we decided we're not gonna do like boot camps where we have thousands of students and we teach in a group. No, that's not how we can do this. We have 4 students right now, and with each of them we work on individually. Right, so each of them have different projects. They work on different data sets, a different problem statement. Right, so one of them is working, let's say, on say predicting sales revenue and so on. The other person is working on customer segmentation, or the third person is working on customer lifetime value and so on. But it's an end to end, and it's one-on-one basis, right? So that's what you get out of this. So if you want to learn more about this, and if you want to get more information about this, feel free to reach out to us on LinkedIn, or you can also email us. So there's a form link that we can share with you guys, so you can feel free to fill out that form as well. And yeah, we'll be happy to walk you through in-depth detail, and you can then decide if you wish to join or not. And one of the final thing I want to mention is we're not charging as much as boot camps, because we realize boot camp charge a lot. We are probably not even charging 10% of whatever they're charging. So even, I think we charge less than 5% of whatever boot camps are charging. But yeah, feel free to reach out to us. If you have any questions, feel free to let us know. Otherwise, that's a wrap.
Okay. So yeah, I'm ending the stream now.